We already discussed about the Newton's rings and its arrangement and the formation of the dark and bright rings. Also about the general equation for the radius of the dark. So in this video, here we are going to discuss about an application of Newton's rings experiment. Okay, the Newton's rings experiment is used to find the wavelength of the light as well as the refractive index of the some liquids. Okay, so in this video we are going to find how to calculate the wavelength of the light using Newton's rings arrangement, which is similar to air wedge experiment, but the pattern is different, so there will be some different techniques to take the readings, right? So in this video we are going to derive, or we are going to discuss about the how to calculate the wavelength of light using Newton's rings arrangement. Okay, for that we already have an equation. We have the general equation for the diameter of the dark ring, which is given by the diameter of the dark ring is given by dn is equal to root of 4rn lambda. Okay, that is the diameter of the dark ring. Equation for the diameter of the nth dark ring. Okay, r is the radius of curvature of the lens, n is the order, and lambda is the wavelength. Okay, so this is the general equation for the nth dark ring. So we can write d1 is equal to root of 4r into 1 lambda, d2 is equal to root of 4r into 2 lambda. Similarly, dn is equal to root of 4r into n lambda, and dn plus 1 is equal to root of 4r into n plus 1 lambda. Okay, and dn plus 2 is equal to 4r into n plus 2 lambda, etc. dn plus k is equal to root of 4r into n plus k lambda. K is any random number starting from 1, 0, 1, 2, 3, etc. Okay, so here we have the equation for the nth dark ring dn, which is dn is equal to root of 4rn lambda, and dn plus k, which is equal to 4r into n plus k lambda. Okay, so by using these two equations, this is my first equation and this is my second equation. Okay, by using these two equations, I'm going to find the wavelength of light. So for that, I'm squaring this because this is inside the square root. So to make it more simple, I'm squaring equation 1 and equation 2. So while squaring equation 1, I'll get dn square is equal to 4rn lambda. Okay, dn square is equal to 4rn lambda, and dn plus k square is equal to 4r into n plus k lambda. Okay, dn square is equal to 4rn lambda, and dn plus k square is equal to 4r into n plus k lambda. So what I need to find? I need to find this thing lambda. Okay, so this is my equation number 3 and this is my equation number 4. So I'm going to subtract 3 from 4. Okay, so I'm going to do equation 4 minus equation 3. So d square n plus k minus d square n, which is equal to 4r into n plus k lambda minus 4r n lambda. Okay, expanding this term, we will get 4r n lambda plus 4r k lambda minus 4r n lambda. Okay, so these are the terms which I am getting. So here there is a 4r n lambda. Here also there is a 4r n lambda. So what we will get? D square n plus k minus d square n is equal to 4r k lambda. Okay, d square n plus k minus d square n is equal to 4r k lambda, and lambda is equal to d square n plus k minus d square n divided by 4rk. Okay, this is the equation to find the wavelength of the light used. Now, how to conduct the experiment? Now, see how to conduct the experiment. So, while doing the experiments, we will be getting the diameter of first ring, okay, second ring, third ring, fourth ring, etc. Okay, there will be a number of rings, so we will be getting the values of a number of rings. Suppose this is my nth dark ring, this is my n plus 1, this is my n plus 2, this is my n plus 3. Okay, so this is the values which I am getting. So while doing the experiments, the center dark spot, then we will be having the alternate dark and bright ring. So we will be measuring the first ring, second ring, third ring, fourth ring, like that. So I am getting the first ring and I'm assuming that is my nth dark ring, second ring dn plus 1, third ring dn plus 2, fourth ring dn plus 3. Okay, so next, what is my equation? Lambda is equal to d square n plus k minus d square n divided by 4rk. Now, this thing is a constant value, right? This radius of curvature is a constant value. We need to find k. Now, suppose my dn is first ring. Okay, dn is first ring. And dn plus 2 is my dn plus k. Okay, so lambda is equal to d square n plus 2 minus d square n divided by 4r into, what is k? N plus k minus n. Here n plus 2 minus n, right? So n cancel, the remaining value is 2. That's why I have written 2 here. So the equation becomes d square n plus k. This is my equation. That is d square n plus 2 minus d square n divided by 4r into 2 lambda. Now instead of this value, so I am taking, this is again my nth value and this is my n plus k. So what will I get? Lambda is equal to d square n plus 3 minus d square n divided by 4r into, what is n plus 3 minus n. So I'll get 3 lambda. So we will be getting a number of values. What we do, we will be measuring the diameter of all the possible rings and we will be subtracting. Okay, to avoid the error, we will be doing some techniques. We will be applying some techniques. But this is the basic method how to calculate the value of wavelength using this particular experiment. I hope you understood. And let's do the experiments in the lab so you will get a better understanding about it. Thank you.